A bridge linking Europe and Africa sounds like a game changer, yet it doesn't exist. From extreme ocean depths to intense political debates, the dream faces obstacles on every front. Today, we'll uncover the fascinating mix of geography, engineering, and diplomacy that keeps this connection off the map. The geography of the Strait of Gibraltar. The Strait of Gibraltar is a narrow waterway connecting the Atlantic Ocean to the Mediterranean Sea, separating southern Spain from northern Morocco. Its width varies between 13 to 44 kilometers, while the depth reaches over 900 meters in some areas. These dimensions create significant challenges for any potential bridge or tunnel. The strait experiences strong tidal currents and frequent winds, complicating construction. Additionally, its strategic location has made it a vital shipping lane for centuries, hosting thousands of commercial vessels each year. The seabed's complex geology, including deep underwater cliffs and sediment deposits, adds another layer of difficulty for engineering projects. Understanding these natural factors is essential to grasp why connecting Europe and Africa via a bridge remains such a daunting task. Historical proposals for a Europe-Africa bridge. Over the last century, several proposals have been made to connect Europe and Africa. Early concepts focused on suspension bridges or floating structures, but lack the technology to withstand extreme depth and currents. During the 20th century, engineers and architects explored tunnel options under the Strait of Gibraltar, inspired by projects like the Channel Tunnel between the UK and France. Governments in Spain and Morocco occasionally discussed cooperation, but plans were repeatedly shelved due to financial and technical barriers. Academic studies also proposed combined bridge tunnel solutions, blending bridges for shallow areas with tunnels for deeper sections. While visionary, these historical projects highlight how ambition meets natural and political constraints, showing that bridging continents is more than just an engineering challenge, but a matter of timing, resources, and international agreement. Political and diplomatic challenges. Any project linking Europe and Africa would require unprecedented political cooperation. Spain and Morocco would need to align on border control, security, and customs regulations, while the European Union might also influence planning and funding. Diplomatic tensions in the region, often tied to migration, trade disputes, and territorial waters, add complexity. International bodies such as the UN and maritime organizations would need to approve plans due to the strait's importance as a global shipping corridor. Decisions about ownership, maintenance, and liability in case of accidents would require detailed treaties. Historical mistrust between governments in North Africa and Europe can further delay agreements. These political and diplomatic hurdles demonstrate that even with the right technology, a bridge would demand long-term international collaboration, careful negotiation, and alignment of multiple national and supranational interests. Environmental and wildlife considerations. The Strait of Gibraltar is an ecological hotspot, home to unique marine species and a critical migration corridor for birds and fish. Construction of a bridge or tunnel could disrupt cetaceans like dolphins and whales while altering water currents and sediment flow. Coastal ecosystems on both the European and African sides would face potential habitat loss, affecting fishing communities. Noise, pollution, and artificial lighting are additional threats to wildlife. Environmental impact assessments would be mandatory, involving marine biologists, ecologists, and conservationists to identify mitigation strategies. Any construction plan must consider climate change, rising sea levels, and extreme weather patterns, which could worsen the ecological footprint. Economic costs and funding barriers. Constructing a bridge across the Strait of Gibraltar would be an astronomical investment, potentially exceeding hundreds of billions of dollars. Expenses include materials, labor, land acquisition, and maintenance, while additional costs arise from security infrastructure, environmental mitigation, and international legal compliance. Private investors might hesitate due to uncertain financial returns, as tolls or transport fees may not cover initial expenses for decades. Governments would face difficult decisions about budget allocation amid competing priorities like healthcare and infrastructure at home. Multinational loans, bonds, or partnerships could be considered, but coordinating funding between Europe and Africa adds complexity. Historical megaprojects, such as the Channel Tunnel, provide lessons on cost overruns and delays, illustrating that even with funding, careful financial planning is crucial to ensure feasibility and sustainability. Engineering difficulties, depth, and currents. The Strait of Gibraltar presents extreme engineering challenges due to its depth, width, and strong currents. Water depth reaches nearly 900 meters, far deeper than most existing bridges. Tidal forces and wind patterns add dynamic pressures that traditional bridge designs may struggle to withstand. Foundations must anchor securely in a seabed with rock formations, sediment layers, and seismic activity, increasing complexity. Floating bridge concepts face stability issues, while tunnel options require advanced boring technology and high-pressure waterproofing. Engineers must also accommodate ship traffic, ensuring clearance for massive vessels navigating the strait. Safety considerations, such as earthquakes, storms, and maintenance access further complicate construction. Seismic activity and geological risks. The Strait of Gibraltar lies near a tectonically active zone where the African and Eurasian plates interact. This region is prone to earthquakes, which pose serious risks for any structure spanning the strait. Bridge foundations would need to withstand strong seismic forces, while tunnels must resist underground shifts and fault lines. Submarine landslides and underwater rock instability are additional hazards, potentially damaging foundations or blocking access points. Engineers would have to implement advanced monitoring systems, reinforce materials, and flexible designs to mitigate risk. Historical earthquake records show magnitude fluctuations that could affect long-term durability. Understanding these geological risks is critical for planning, highlighting that natural forces alone present formidable barriers to connecting Europe and Africa beyond just depth, currents, and political factors. Shipping lanes and maritime traffic concerns. The Strait of Gibraltar is one of the busiest maritime corridors in the world, handling thousands of commercial vessels annually. Any bridge would need to allow sufficient vertical and horizontal clearance for container ships, tankers, and cruise liners. Construction and maintenance could temporarily disrupt trade flows, causing economic ripple effects. Tunnels also pose challenges, as underwater construction must avoid interfering with navigation charts and port operations. Safety measures would be essential to prevent collisions, oil spills, and accidents, which could cripple global trade. Coordinating with international maritime organizations is mandatory to ensure compliance with shipping regulations. This makes the strait not only an engineering obstacle, but also a logistical puzzle, demonstrating that human activity on the water significantly complicates efforts to connect two continents. Impact on trade and travel if built. A bridge or tunnel linking Europe and Africa could revolutionize trade and travel. Freight transport would become faster, reducing shipping costs between Mediterranean ports and North African markets. Tourism could also benefit, with easier access encouraging cultural exchange and economic growth. Shorter travel routes might attract new business investments, boosting regional economies. However, initial construction could disrupt existing shipping lanes, requiring careful traffic management. Long-term, maintenance and toll policies would influence profitability and accessibility. While the structure could serve as a symbol of continental integration, it would also shift logistics patterns, affecting airlines, ferry companies, and port operations. Security and border control issues. A physical link between Europe and Africa introduces complex security challenges. Authorities would need robust systems for immigration, customs, and counter-terrorism, managing thousands of daily crossings. The bridge or tunnel could become a target for criminal activities, smuggling, or unauthorized migration, requiring advanced surveillance and patrols. Cooperation between Spain, Morocco, and international organizations would be essential to enforce legal frameworks and maintain safety. Infrastructure design must integrate checkpoints, monitoring stations, and rapid response measures without causing traffic congestion. Balancing security and convenience are a delicate task, as overly strict controls could discourage travel, while lax measures increase vulnerability. Future possibilities and emerging technologies. Technological advances could eventually make a Europe-Africa connection feasible. Innovations in underwater tunneling, high-strength materials, and earthquake-resistant engineering may overcome current limitations. Floating bridge technologies, autonomous construction drones, and AI-driven maintenance systems could reduce costs and improve safety. Environmental monitoring with real-time sensors would minimize ecological impact, while smart traffic systems ensure smooth transit. Hybrid designs combining bridges, tunnels, and ferries may become more practical. As global demand for intercontinental trade and travel rises, private investors and governments may revisit proposals. These emerging technologies highlight that what seems impossible today could be achievable tomorrow, but success requires aligning engineering innovation, environmental responsibility, and political will on an unprecedented scale. The idea of a Europe-Africa bridge may seem futuristic, but the challenges are very real. Whether it ever becomes reality, it sparks curiosity about human ambition, engineering limits, and the power of geography. Thanks for watching, stay curious, and keep exploring the world's untold stories.